Assalamu alaikum to all my students. This is XII online support program and your class is second year. Okay, you can see that today we'll discuss question number 6 to question number 9 from exercise 2.7, and this is the remaining questions from the previous lecture. That in previous lecture we have started exercise 2.7 and question number 1 to question number 5 we have done it. And in this presentation, in this lecture, you can learn question number 6 to question number 9. Okay, so I'm just starting question number 6 with the name of Allah. Bismillahir Rahmanir Rahim. Now, question number 6. Question number 6, that is one thing is given, that is if y is equal to e raised to the power x sine of x, means two functions that are into u into v shape, means product form. And what we have to prove, show that d square y upon dx square means second derivative minus 2 times of first derivative plus 2 times of original function. That was the original function, and all the things it should be equal to 0. That we have to prove this. Okay, so first of all I'm just picking the original function that is given, y is equal to e raised to the power x sine x. Now I'm just differentiating with respect to x. So y differentiate with respect to x, dy by dx, and d upon dx is here. Means d upon dx and d upon dx I am applied on the both sides. So y is here and e raised to the power x sin x is here. And you can see that two functions are in product form, so u into v form. What is the formula of u into v? U same v derivative plus v same u derivative. I am repeating again. U same v derivative plus v same u derivative. So what is u? U is e raised to the power x. What is v? Sine of x. Okay, and you know very well that when d upon dx or the operator has applied from the function, so we have to derivate. So what is the derivative of sine x? Sine x derivative is cos x, and ex derivative is ex. So how many terms are there? Yes, there are two terms. What is common? E raised to the power x is common, so cos x plus sin x is common. Okay, so cos x plus sin x is remaining, not common. Okay, so now this is the answer of the first derivative, but for the sake of the result we have to take again derivative because we want second derivative of this function. So again differentiate with respect to x. So operator is again applied, d upon dx is the operator, dy upon dx. Why d upon dx is the operator? Because differentiate with respect to x. If we differentiate with respect to t, so d upon dt was the operator. Okay, so dy upon dx is equal to d upon dx and the operator. Now you can see again u into v is applying here. U same v derivative plus v same u derivative. Okay, u same v derivative plus v same u derivative, and you know that there is e of x is common, so minus sin x plus cos x plus sin x only remaining. So 2 cos x e 2 ex cos x is the second derivative answer. Now just take out the left hand side. This is the left hand side. Just put it the value second derivative 2 times derivative in this here, and first derivative here, and original function here, like this, and you can see that all the thing can cancel, so this whole thing is equal to 0. Okay, now question number 7. If y is equal to e raised to the power ax sine bx, then show that a of y dx square minus 2a dy, that is d. Okay, d of y dx square minus dy square upon dx square minus 2 of a dy upon dx plus a y plus b square y is equal to 0. Okay, so what we need to prove, again we need second derivative because of this operator. We need for the second derivative we need first derivative, and we need a function, original function, that is y. So just like previous question number 6, you can see here u into v, we have to apply u same v derivative plus v same u derivative. Okay, so sine bx means angle. Okay, box. Sine box derivative is cos box and box derivative. What I said, cos box and box derivative. Bx derivative with respect to x, only b, and then sine b of x, e raised to the power ax, and e raised to the power x, ax derivative is e x dot a. Why dot a? Because box derivative we have to multiply with the original derivative. Okay, for the sake of chain rule. Now there is two terms, e of ax is common, so b cos bx plus sine a sine bx is the answer of first derivative. So for second derivative, this is little bit difficult from first derivative, because in the answer of first derivative is this is a little bit long. Okay, you can see here. So u same v derivative plus v same u derivative. Again you can see u same v derivative means derivative should be applied on this term and this term as well, and this is same, and derivative of e of ax is e of ax plus a. Okay, now when we apply derivative to this term, so b cos bx dot b. Why dot b? Because b cos bx derivative is, b is the coefficient, so b is remaining same. Cos box derivative is minus sine box, and box derivative is b. Now again, a is coefficient, same. Sine bx derivative, sine box derivative is cos box, and box derivative is b. Okay, this is remains same. Now you can take the common, e of ax is common, so after the simplification you can get this thing. So after second derivative result, now you can put it in the original equation or required equation, you can say. So answer is this should be 0 equal. Okay. Question number 8. If y is equal to cos inverse of x raised to the power square. Now this is a little bit difficult function. If y is equal to cos inverse of x and then square, okay, the whole square of this. And first of all you can think that can this minus 1 multiply by 2? No. Why? Because it is a function, inverse function. So this minus 1 cannot be multiplied by this 2. Okay. So cos inverse x, the whole function, and then complete square. What we need to prove? Prove that 1 minus x square y2. What is y2? I told you in previous lecture, y2 means second derivative. Okay. Minus x y1. What is y1? y1 means first derivative, minus 2 is equal to 0. Now what was given? Y is equal to cos inverse x, whole square is given. So I'm just differentiating with respect to x. So if whenever you can see the power, the whole power, we have to apply the power rule. How many tasks we have to do in power rule? There are 3 tasks. First you write the power at the bottom, then decreasing the one power with the original function, and then derivate under the power. Now again I am repeating with the laser pointer. First you write the power at the bottom, then decreasing the power 1 from original function, then 2 minus 1 is 1, and then derivative of under the power. This is power rule. Okay. Now 2 cos inverse x is same, and you know that we have learned the formula that cos inverse x derivative is minus 1 under root 1 minus x square. Okay. So this is first derivative, that y1 is under root 1 minus x square. I am just cross multiplying y1 under root 1 minus x square is equal to minus 2 cos inverse x. So I am squaring on both sides to remove the square root. Squaring on both sides, y1 is square, 1 minus x square is equal to 4 cos inverse x raised to the power square. And now you can see cos inverse x raised to the power square is equal to what? This is for y. So y1 is square, 1 minus x square is equal to 4y. I told you. Now again I am differentiating y because I want to reach to y2. So again differentiate with respect to x. So y1 is square, 1 minus x square and 4 dy by dx. So now this is u into v, we have to apply u same v derivative plus v same u derivative. This is same. 1 minus x square is same. y1 square is 2y1 dy by dx. Power rule. And 1 minus x square is minus 2x. That is the answer. 4y1 y4 y1 is the answer. Why? Because dy by dx I put it down in the sake of y1 y2. Okay. Now after the simplification you get this thing and you have proved the whole scenario. Okay, now question number 9. If y is equal to a cos of ln x plus b sin ln x, prove that x squared second derivative y plus x first derivative plus y is equal to 0. But you need to prove. Okay, what is the function? Y is equal to a cos ln x plus b sin ln x. I just took the derivative, first derivative differential with respect to x. So y derivative with respect to dy by dx. A cos box derivative is a minus sine box and box derivative. A minus sine box and box derivative. Okay, plus b sine box means b cos box and box derivative. B cos box derivative. Okay, and box derivative ln x derivative is 1 upon x. 1 upon x is common. Okay, so I'll just take the common and then multiply by there. Okay, so x dy by dx minus a sine ln x plus b cos ln x. Again I am differentiating because we need to reach at d square y upon dx square means second derivative. So again derivative. So you can see the whole thing, and this is same as question number 8, 9, question number 8, question number 7. So in the definitely you know how to do it because it is only simplification. Okay. And if you have any question regarding these steps, so you can ask. I'm live through the WhatsApp group, so you can ask any question. Thank you for your attention. Allah Hafiz.